All right, today we're diving into something you've probably never heard of, but it's an absolutely critical procedure that protects billion-dollar machinery. It's a totally invisible process, but believe me, the consequences are very, very visible if it goes wrong.
So let's just jump right in with a question. Picture a 100-ton gas turbine. I mean, this thing is the massive, beating heart of a power plant or an offshore oil rig. What do you figure is its biggest threat? Some kind of epic mechanical failure? A natural disaster, maybe? Well, the answer is this: 5 microns. To give you some perspective, a single human hair is about 70 microns thick. So the greatest enemy of a machine the size of a small house is a particle so small you literally cannot see it. Kind of crazy, right? And that really gets us to the core of the problem here. This microscopic threat that's just lurking deep inside some of the most important industrial equipment on the planet. So what exactly are we talking about when we say microscopic threat? Well, it's not some exotic chemical. It's actually just the grime and leftovers from when the machine was built. Things like tiny bits of welding slag, rust, metal shavings, even sand and dust. Basically, it's like having sand in the gears of a very, very expensive system. And the stakes here are just massive. These tiny particles can bring an entire industrial giant to a grinding halt. We're talking about the kind of machinery that powers our world: LNG plants, huge refineries, offshore platforms. All it takes is one tiny piece of grit in the wrong place at the wrong time, and you're looking at a catastrophic failure. Okay, so how in the world do you fight an enemy that you can't even see? Well, you fight it with a really specialized, really powerful cleaning technique that was designed for this exact battle. It's called Lube Oil Flushing, and the concept is actually pretty simple, even if the work itself is super precise. You're circulating oil through the machine's lubrication system. It's arteries, basically, but at an incredibly high speed. The whole point is to literally scrub the pipes clean from the inside out. Honestly, the best way to picture it is this. Think of a power washer for the inside of a machine. This isn't just a gentle rinse cycle. No, no, no. This is an intense, high-pressure blast that's designed to dislodge every last thing that shouldn't be in there. But how does that power washing effect actually work? I mean, it's just oil in a pipe, right? Well, this is where it gets really, really cool. It's all about harnessing the physics of how fluids move. See, it all comes down to two kinds of flow. During normal operation, oil moves in what's called laminar flow. It's smooth, it's orderly, it's like a lazy river where all the dirt and debris just sits on the riverbed. But lube oil flushing creates turbulent flow, and that is chaotic, it's powerful. It's like a raging river that churns up everything from the bottom and carries it downstream. That's the scrubbing power. So, how do you create that raging river inside a pipe? Well, engineers have a magic number they're aiming for. It's called the Reynolds number, and the goal is to get it above 4,000. That's the tipping point. It's the exact moment where that smooth, lazy flow just collapses into chaos and creates all those powerful, swirling eddies that do the actual cleaning. That's the whole game. And here's the recipe for making it happen. First, you need high velocity. You pump the oil at up to 3 times its normal speed. Second, you use high temperature. You heat the oil up to make it thinner and less sticky so it flows even faster. And third, you need some serious muscle, which comes from huge external pumps that provide the horsepower to get the job done. Okay, so we get the why and we get the science behind it. Now let's look at the how. What does this whole operation actually look like when you're out there doing it? It's basically a 5-step playbook. First, you have to prep the system, which means bypassing any sensitive parts like bearings that could get damaged. Then, you heat the oil and get it circulating to create that turbulence. Step 3 is where the real deep cleaning happens. You're scouring the system, and sometimes crews will even hammer the pipes or use hot and cold cycles to shake loose really stubborn gunk. The whole time, the oil is running through super fine filters, and you're constantly checking how clean it is. Once it meets the standard, you put everything back together and you're ready for a fresh start. But that brings up a really important question, right? In a system where the enemy is microscopic, how can you be 100% sure the job is done? How do you prove it's perfectly clean? You can't just look inside the pipes with a flashlight. So engineers have to act like forensic investigators. They have a whole set of strict tests they run to gather undeniable proof that the system is spotless. And this is the final scorecard. It's an international standard called ISO 4406, and it's not a suggestion, it is a hard and fast target. To hit a common cleanliness code like this one, you need to have fewer than 5 particles larger than 14 microns in a whole milliliter of oil. We're talking about an unbelievably high standard of clean. But it has to be, because in one of these machines, even one particle that size is a big problem. So to prove they hit that number, they collect 3 key pieces of evidence. They use laser particle counters to get the official ISO code. They do a mesh screen inspection, where a superfine screen has to come out totally clean after an hour of flushing. And finally, they do what's called a patch test. They put a drop of the oil under a microscope just to see with their own eyes that it's free of junk.
So we've seen the threat, the really clever solution, and the proof of cleanliness. Let's just wrap it all up and answer the most important question. Why does all of this incredibly detailed, complex work matter so much?
Well, here's the payoff. This whole thing isn't just about cleaning pipes for the sake of it. It's about preventing catastrophic failures. It's about making multi-million-dollar assets last longer. It's about avoiding operational downtime that can cost a company hundreds of thousands of dollars a day. It is absolutely fundamental to keeping these things running reliably.
And if that's not enough, get this. There are huge financial stakes, too. For new equipment, if you don't do this or don't do it right, the manufacturer can just void your warranty. That's how critical it is. It's not an optional add-on, it is a basic requirement for operating modern industrial machinery.
When you think about it, lube oil flushing is a perfect example of a hidden, high-stakes procedure that has a massive impact. And it kind of makes you wonder, right? What other invisible, incredibly complex jobs are out there happening behind the scenes right now just to keep our modern world running?